looks different.
Okay.
No jokes on that, bro.
Not till next week. In 2.4, we are going to look at other characteristics of functions. So we've already looked at like x and y intercepts and domain and range. And now we're going to talk about 3 other ways that we can describe functions or key features, key characteristics of functions. So on the first tab you see, we're going to look at where a function is positive and negative. Look at increasing and decreasing. Which one? That's our end behavior. So really all we're doing is look. So if you are to open up that tab, we're going to go ahead and fill in the blanks. A function is positive when its graph lies above the x-axis. And a function is negative when the graph lies below the x-axis. So when we are asking, or when we're being asked to describe where the graph is positive and where the graph is negative, all we're doing is looking for the parts of the graph that are above and below the x-axis. So I always think about that x-axis as like sea level. If it's above sea level, then that's where it's positive. If it's below sea level, then that's where it is negative, okay? When you are looking for these intervals, I'm going to put a little asterisk here. What you need to be looking for is look at the x-intercepts. Because where the graph crosses the x-axis would be where the graph goes from above to below or from below to above. So we're looking for those points on the x-axis that will help us describe where it's positive, where it's negative. Okay? So let's first look at this linear function. Once again, here's our x-axis. It's kind of like sea level. And right here, this point where x is equal to 2, that's where this graph goes from above the x-axis to all of a sudden below. So this graph was positive until 2. So when we describe this in terms of that x value, this graph was positive where x was what to 2? Less than 2. Not or equal to, because at 2 it's not positive or negative, it's at 0. Okay? So this graph was above the x-axis before negative 2. So for all those x values that are less than negative 2, that's when that line is above the x-axis. Then at 2, it now drops down below the x-axis. And it's going to stay below the x-axis. So it will be negative or below the x-axis wherever x is what than 2? Greater than 2. So we describe where a graph is positive and negative based on those x-intercepts and using those inequality symbols. Okay? All right. Let's look at this quadratic. So now what you'll notice, if we look at this x-axis, we have 2 x-intercepts. We have this x-intercept at x equals -4. And then an x-axis right here where x is equal to 0. So think about this graph kind of like a dolphin jumping out of the water, right? It's under the water, and then for this certain amount of time, it's jumping out of the water, and then it goes back into the water. So this graph, this time, when we are talking about where it's positive, this graph is negative, then positive, then negative again. So it's positive in between these 2 x-intercepts. So we're going to write that like a compound inequality. So from -4 to 0, that's where it's above the x-axis. So wherever -4 is less than x, but x is less than 0. So in between -4 and 0 is where that graph was positive, because it's where that graph was above the x-axis. All right? Now, it's below in 2 different places, right? We were below the x-axis until we got to -4. So the x values before -4 are, no, less than. X values before -4 are less than. So it's negative where x is less than -4. And in one other spot, because then we go negative again after 0. So wherever those x values are what to 0? Greater than 0. Yes. Okay? The only way we're going to get comfortable identifying these is practice. That's why I say if there's a day you do practice, make it today. Because it's going to be negative to the right of 0. And so all these values to the right of 0 are greater than. Question?
Why did you do an and at the bottom one?
Because this is negative in two different places. Before 4 and after 0. Where the positive, it's positive in between these two values, not in two different places, in between -4 and 0. So I write that as one compound inequality. But this was negative in two separate places that were split up. Because it was negative, then positive, then negative. So I have to write the negative as two different intervals. Okay? All right. So that is positive and negative, which means above and below. Now let's look at our second flap, which is something different. So a function is increasing when its graph moves up as x moves to the right. And a function is decreasing when its graph moves down as x moves to the right. So anytime we're looking at graphs, remember it's just like reading a book. We're looking at it from left to right. So if I were to trace this graph from left to right, my finger is going up and then down and then back up again. So this example graph has two different places where it's increasing. And then, so it's increasing here and it's increasing here. And then we have one place where it's decreasing. So the point that you need to look for here when you are trying to describe those intervals of where it's going up and where it's going down, we want to look for the turnaround points is what I'm going to call them. Look for the turnaround points. Meaning we're looking for those minimum and maximum values. We're looking for those points where the graph was doing something and then all of a sudden it turned and did something else. So in this example graph, this graph was increasing until this point right here and then we started going down. So this is a turnaround point, then we started going down and this is a turnaround point. So when we're describing where it's increasing and where it's decreasing, we're going to be using the x values of these turnaround points. So this point has an x value of -1.
Ms. Burden?
Yep.
I need Alex Garcia to the office.
He's on his way.
Thank you.
I probably should have said yes, not yep. So we are looking for these x values, or the x values of these turnaround points when we describe the intervals of where it's going up and where it's going down. Okay? So our line is easy because I just said that if we're describing where it's increasing and decreasing, we're going to look for a turnaround point. Is there a turnaround point on a line? No, which means it's always only doing one thing. In this case, as I look at this line from left to right, what's it always doing? It's decreasing. So for the increasing interval, we'd say never, because it's never increasing. And then for the decreasing, we can just say always, or all real numbers, or for all values of x, it's decreasing, because it's always only doing one thing because it's a line. All right? When we look at our quadratic, well, if we trace that graph from left to right, we've got one of each because we have a turnaround point, which means this graph is going to have an increasing interval and a decreasing interval. And the x value of this turnaround point is at what? -2, right? Yeah, no, -2. Okay, so the x value of this turnaround point is -2. So when we describe these intervals, we're describing them in terms of x and -2. So this graph was increasing first, right? It's going up and then it's going down. So it was increasing before -2. So that's where our x values are less than -2. That's where it was going up. Then, all of a sudden at -2, it started going down. So for any values after -2 is where it's decreasing, after -2. So those are where numbers are greater than -2, right? Like your next birthday, you're going to be older. Wow. Right?
I didn't know that.
So if it's after something, it's greater than. If it's before, it's less than.
You'll see me on the practice.
All right, so that is increasing and decreasing, which is not to be confused with positive and negative. Positive and negative is where it's above and below. Increasing and decreasing is up and down. All right, last one, which is the easy looking at. What's the graph doing to the left and what's the graph doing to the right? So what I suggest we all look for here are these arrows. This is the right side of the graph. This is the left side of the graph. So the way we read this notation, this is as x approaches infinity. So positive infinity on the x-axis is the right side. So as x is approaching infinity, what is y doing? So on the right side of the graph, this arrow is pointing up, which means y is also approaching infinity. And then this, as x is approaching negative infinity, well, negative infinity for x is the left side. What's that arrow on the left side doing? It's pointed down, which means it's also approaching negative infinity. Okay? So, let's look at our line example. So this says, as x approaches negative infinity, so that's the left side. As x is going towards negative infinity, this arrow is moving in which direction? Up, which means our y is approaching positive infinity. And then the second statement, as x is approaching positive infinity, so now I'm looking at the right side of the graph. Well, the arrow on the right is moving down, which just means negative infinity.
Wow.
All right. Our quadratic is a little easier because both of these arrows are moving in which direction? Down, which means no matter if my x's are approaching negative infinity or positive infinity, my y values are always moving towards which direction? Negative infinity.
Wow.
All right.